Hey YouTube, welcome back to the channel. It's your boy, Taicho, and that's my NetNavi X. We're on a journey to conquer the other net. So we're just going to jump right into it. If you've been following the series so long, we began our piracy journey by setting out to create a one-piece database. How we've done so far, in a really short recap, is we're using the One Piece wiki fandom to go and scrape all the HTML data that they've done a great job of collecting and putting into a website format. If you're interested in a detailed breakdown and the step-by-steps on how we've gone to that website and actually scrape the data, I recommend you check out the earlier videos in this series, part 1, 2, and 3, where I go in depth and step-by-step on how we're able to do that. But essentially, as I mentioned, what we've done is gone and scraped the internet data. We worked through cleaning up that internet data, putting it in a more usable format for us, and essentially what we have right now is a data frame of all the different One Piece sagas. We started with the sagas because that's the highest in the hierarchy in terms of the story structure, and as you can see here, we have a link to the saga, we have the name of the saga, and then we have a bunch of different information on its general structure. We have the volume info, the chapter info, the episode info, and then we have a couple of dates in the year format associated with those sagas. So that's where we are. We've done a great job in getting this format and getting this data in a usable format, this data frame that we have. But now we want to, take the next step and actually start to put it in a database. So how we're going to do that, we're going to use SQL Server, and I've essentially wrote out the 4 steps that we're going to complete in order to do so. So the first thing we're going to do is we're going to establish a database connection. Second thing we're going to do is execute data definition language. Third thing we'll do is insert these rows from this data frame into the SQL Server database. And then lastly, we'll commit the actions, which is essentially us giving the okay for the program to save everything that we've done and finalize it. So to set up the connection, we're going to write a couple lines up here to establish the connection. It's going to be pretty straightforward. Basically what we're doing is we're going to define this variable called conXstring, and this will be different for everyone based off the path of where you have your SQL Server and stuff like that, but it'll look something similar like this. We're going to have a driver which allows us to connect to the SQL Server. You're going to kind of have your URL path to it, or not URL path, but your path to that specific directory. You're going to have different names, and then the main thing here is what database you're going to be saving it to. So I have a One Piece database. We're going to put trusted connection equals yes, so I don't have to put in a password and stuff like that. I can automatically connect. And then, we should be able to write these rows of data to this database. So that's the first line. And the reason I'm not using X too much is because we don't have any dark chips for SQL yet, but he will help us with some of the repetitive stuff that comes up. But yeah, so the next line that we do is we define this variable connection. For those of you familiar with ODBC, this is just a way for us to kind of connect with different drivers and different programs. And we're going to use this variable connection string. So we've defined the actual string, the text string of where or what we want to connect, and then this little clip here does the actual connection for us. This will allow Python to write SQL or execute SQL script to the database. Then we're just going to define this other function called cursor, which kind of brings it all together and executes the scripts that we have below. So just those 3 lines will get us started. This will, give us a connection to the SQL Server and allow us to actually write or execute the SQL script. Okay, so now for us to actually execute the SQL script, we're going to have to write SQL scripts, so to say. So we're going to use the cursor, and we're going to type, execute. Basically, we're going to tell it what we want to execute. And because we're doing it in Python, we have to kind of use these 3 like apostrophes up here, so it knows how to interpret the SQL script. And that's going to go at the beginning and the end. So we have to execute that. Okay. So this will be at the end. So we're not doing too many executions. We're really just going to be executing 2 different scripts. The first thing is we have to define the table and its structures, and it should look exactly like the data frame in terms of the columns that we have. So we have 17 columns, so we know we want to create a table that has 17 columns. And the first thing I always do actually is this little drop thing. So basically, if you have a table already created called sagas, you would type this if you want to delete it and then recreate it. And then this semicolon allows the execution to kind of execute multiple lines or multiple SQL scripts, so to say. So this is pretty much one command. And then the second command is we actually have to create the table. This is going to be sagas. We're calling it sagas because we're importing or exporting. We're exporting this Saga data frame into SQL Server. So that's the table we're going to create. And then now we have to put the columns. So we have 17 columns, and essentially it should just be the exact same ones here. And what you would do is you would type the column name, and then you would define the variable. And I'm just going to use varchar because variable character with 150 characters. This will allow pretty much any type of string, numeric value to be inserted. The reason I'm doing this, when I was trying to get really particular and use like integers or big ints, I was running into a bunch of errors, and I think other packages are better equipped to do this, like SQL Alchemy, but we're sticking with this route. So I would say the first column I'm creating is name. It's going to be a character type, and it's going to be able to hold 150 different characters. And we're going to do that for the next 16 variables, but I'm not going to type them out. So X, if you could be so kind as to kind of recreate that line, but for the other characters for us. Cool. So he's given us that, and it's going to look exactly the same. So I'll just borrow his clip that he gave us. And here we go. So everything is going to be the same structure. We have name, variable character, and 150 characters allowed. Let's see. I think I deleted something. So that's going to be the first SQL script that we execute, and that will create our table. It's not going to have any data, but it will create our table. And now that we have our table created, this is down here. Okay. What we could do is insert rows into that table. So in order to insert rows, we're not going to do it one by one. I'm not going to type it. We're just going to use the for loop. If you're not familiar with for loops, check my older videos. I kind of go over an overview of what they do. But we're going to use a for loop, define a couple of variables. And use this iter_rows function, which will pretty much iterate through each row in this Saga data frame and complete the commands that we tell it. And then, so we're writing a for loop, and then for each row, we're going to execute a SQL command, which is the insert into, and we're going to insert into the database object or the table that we just created, sagas. And I'm just going to borrow this, copy this clip. And what it'll look like is basically we're inserting rows into the same column names that we just created up here. You have to follow this kind of bracketed format with the comma. And then at the end you have to do this weird kind of like, you have to have the same amount of question marks here for how many columns you're inserting. So since we have 17, we need 17 up here. I'm not exactly sure why that has to be that way, but it just kind of is what it is. So that'll be the first line, the insert into, and then basically what we're inserting is the row for the name variable in the name column. And this order needs to match exactly this order, and this order for each row needs to match up as well. Otherwise you'll have columns with different, you'll have a column say name, but you might not have the right variable if you don't match it up exactly. So your data will look a little weird. And so I'm going to ask X again, if you could just kind of output the same little syntax here for all the other columns. And we'll do that. Cool. So this is what the insert command will look like. And then the last thing what we need to do is commit our actions. So this will tell us to commit everything that we've just did, or give it the okay to like save the data in there. If you don't commit, it won't save it. It won't be completed. We're going to close our cursor connection. Close out everything at the end, and I'm just going to use this one clip. And I wanted to tell us how long it takes, just to see, how practical it is. We don't have a lot of rows. We only have, I think, like 11 rows, 10 or 11 rows. That's however many sagas there are. So this shouldn't be a super lengthy time process. And so just to show, we have this one-piece database. We have no tables here. So if everything goes right, we should have a new table here. We'll run the script. Hopefully I copy and paste it correctly. Line 134. So let's see what we did wrong. Time. So again, a couple errors. Line 1 times a term. Awesome. 4.2 seconds. This whole script was able to go to a website, scrape some data, clean it up, and then hopefully push it into a format. So now I'll go back to our onepiece database. I will refresh the tables, and we should have something new. Cool. So now we have a sagas table here. I'll right click, click, and select top 1,000 rows. And here's our data. So this is pretty cool. We started with website, really messy information. We scraped it down into Python. We used Python to format the data frame, create some additional columns, clean up a bunch of things, and then push that data to the SQL Server Database, which is it's pretty cool. So now we see we have in a much more easier format to use. This will be saved so that we can query it later on rather than having to run the whole script. And now we'll just go over it. So we have all the different sagas. This is in chronological order. We have the link to the saga, and then we have the volume info, chapter info, episode info, couple counts, when it started, 1997, 26 years, pretty wild. So yeah, this is pretty cool. It's not super perfect, as you could see. For the final saga, if you're caught up, pretty wild stuff going on. I'm not going to spoil it right now. Pretty wild stuff. But you can see it doesn't have any end for the volume info. It doesn't have any end for the episode info, even from Wano, because that's still ongoing. So we'll figure out ways how to kind of patch that up for now. But yeah, this is our database, and the reason we want it in SQL now is because it becomes a lot easier to manipulate. We can always go back to this whenever, but we can write custom queries here if we wanted to. So, if we wanted to select everything from the sagas table, as well as some other things. So say I want to find out how many volumes, chapters, and episodes there are for each saga. We could do it in Python, but we'd have to run that whole script. Or we could come here and write a query, which will make it a little bit easier for us. And I have to use this cast because they're all strings technically, but I'll do cast appn n minus cast app start as int. I'm going to do a +1 so we get an accurate count. And I'll call it episode count. And I'll do that 2 more times. So let's do vol. Call that vol. Call that the vol count. I don't know if it needs these buttons. Okay, and then let's just order it by the chapter count in descending order. So this should work. So basically what it should do is give us this whole table back, and we created a couple more columns, and then we want to order it by the chapter count descending. So hopefully I did this right. This is the case. let's see how we do. Cool. So it gave us the same thing back, and now we can see the chapter counts. But again, so you can see for Wano country, it's not over, and we have blanks, so it's giving us negatives. We'll clear that out later on. I'm sorry, for the episode count. But you can see for chapters, 150 chapters of Wano, 150 chapters of Dressrosa, 139 chapters for Water 7 Saga, all the way down. So we have the shortest and most forgettable saga, Thrilled Bark. Fishman Island Saga, 56 seems a little bit short. Fishman Island was pretty good. I didn't hate it, aside from the nosebleed stuff. Sky Island, East Blue, here are the middle ones. But yeah, this is where we are. We're at a great start. We finally started our One Piece database with our sagas table. It's a great start in our, moving forward. What we're going to do now is kind of expand. We have limited data, albeit in a good format. We're going to add the ARC data in our next video, or start to work towards that. So I hope you really are enjoying the series. If you're coming from an analytics background or analytics side, let me know what you think about this passion project. Any ideas, tips, make it better, or just your thoughts in general. If you're coming from the One Piece side, what kind of data fields do you think you'd be interested in? Or drop your favorite saga and why. But that's all we have for now, and farewell everyone. Taicho out.